Okay, so I'm wondering if you guys can't tell because obviously. So I'm doing this again, my third attempt at this video. Explain whether the following equations are proportional. We're not comparing them to each other, so let's take this case separately. And in this one, we know this is proportional because what's the y-intercept here? The y-intercept is 0, right? Remember, when there's nothing, the b is 0. So I know this crosses or starts or crosses the origin and goes like this. It's positive. And because it goes through the origin, it's going to be proportional. I'm going to take another approach, and I'm going to show you that with a table. So I'm going to pick some values, 1, 0, 1, 2, 3, that's it. And let's see what happens. When x, and then I'm going to change this equation just to write 1.5x. Because it's easier to multiply. When x equals 0, it's 1.5 times 0, so this y would be 0, and therefore there's my, right, that would be 1 point in that line. When x equals 1, it'd be 1.5 times 1, and you get 1.5. When x equals 2, 1.5 times 2 is 3. When x equals 3, 1.5 times 3 would be 4.5. So you would have those points on the line, and you can tell that they are proportional. Right, now another way of finding if they're proportional, and you can use this particular k equals yx, and you can do that for each of these points here and see if the constant of proportionality is the same. So y is 1.5, and 1.5 over 1 is just 1.5. Second one here, we're going to get k equals 3 over 2, and 3 over 2 is the same thing as 1.5. And the last one, you get k equals 4.5 over 3, and likewise it becomes 1.5. Right? So you can tell that this is proportional, and that you can see that relationship going this way. It's times 1.5 for each of these. The next one, it's if you think about the graph itself, and you were to graph it, I have a equation here where the y-intercept is b, so it's gonna cross this point right here, and it's not going through the origin. It's not going to go through 0, 0. So this line is going to go like that, right? So, and we're going to ignore the negative numbers, but if I'm just showing you that this line would cross the y-axis there, and it is linear, but it's not proportional, and I'll show you how it's not proportional by putting up some numbers. So let's pick 0, 1, 2, 3. When x is 0, it'd be 3/5 times 0 plus 3, and y equals 3, and that's my point right here, 0, 3. Right? When x equals 1, when x is 1, I would put the 1 over here, substitute for y. 3/5 times 1 is 3/5, plus 3 would be 3, and 3/5, and I'm gonna I want to change to a decimal, 3.6. When x equals 2, it'd be 3/5 times 2, which would be 6 over 5, right? So when x equals 2, and you want to substitute, and you would get y equals 3/5 times 2, and then plus 3. 3/5 times 2 is 6 over 5, plus 3, and 6 over 5 is the same thing as 1 and 1/5. Plus 3, you could get 4 and 1/5, or 4.2. And the last one is, what do you call it? It would be 3/5 times 3 plus 3. 3/5 times 3 is 9 over 5 plus 3. And 9 over 5 is 1 and 4/5 plus 3. And that would give you 4.8. Right? So now, if you look at, and if you were to find the constant of proportionality here, constant of proportionality is the unit rate. And the unit rate, it's, well, you can see it clearly. It's, unit rate is when we're comparing to 1. In this case, it's 3.6. But just to, you use k equals y equals x to find a constant of proportionality, or the unit rate. Y is 3.6, x equals 1, or just 3.6. So my constant of proportionality is 3.6. Now let's see over here if the constant of proportionality is also 3.6. So I get y, which is 4.2, and I divide that by 2. And 4.2 divided by 2 is 2.1, which is, You can tell they're different. And last one is k equals 4.8 over 3. And 4.8 divided by 3, I believe, is 1.6. And you can tell that they are all different. Right? The unit rate for this one is 3.6. The unit rate for this one is 2.1. And the unit rate for this one is 1.6. Okay, so they are not proportional to 3. So like over here, on this side, let me just use this space. On this side, so if I were to put that as a fraction, I get 1.1 over 1 and 3 over 2. Are these proportional to each other? Well, you can clearly see times 2 relationship and times 2 relationship. If even with 4.5, which equals 4.5 times 3, it would be a times 3 relationship and times 3 relationship, and it works out. In this case, it does not work at all. Okay, because they're not proportional. Let's move on. What is the constant of proportionality? So again, it might be easier if the table is set this way. So assuming that this is a table where it's proportional, let's just write that y equals 30. So be careful. 30, 36, 39, 42, 20, 24, 26, 28. So assuming this is a proportion, there, you can pick any of these values to find a constant proportionality. So let's use this one. And you get k equals y over x. Be careful here. It has to be y over x. And k equals 30 over 20, or k equals 3 over 2. I'm just going to pick this last one, because just to show you that it didn't matter which one you picked. K equals y over x, which is 42 over 28, and hopefully that's the same thing as 3 over 2. We can divide top and bottom by 14. 42 divided by 14 is 3. And 28 divided by 14 is 2. And you can tell that it's the same. So clearly the unit rate here, 30 over 2. Right, so I'm just making this up. Let's call this money. Let's call this hours. This person makes $30 in 20 hours, or $36 in 24 hours, $39 in 26 hours, or $42 in 28 hours. All these four, whichever one it is, if you were to find the unit rate would be $3. Sorry, not $3. The unit rate would be 1.5 over 1 hour. So every hour you'd be making $1.50. Okay, so that's our unit rate. Okay. No, that's it. 9, if an equation is proportional, then the graph will always, think about the graph. If it's proportional, it will always go from 0 to wherever. Okay, so it will always go through the origin. It has to. Okay. Find a constant proportionality. Well, this one is what I would do. Constant proportionality, remember it's k, y over x, so you have to pick a point. Usually we pick a point. So again, this one's pretty simple, but you could have picked this point because they meet right at the intersection. Is there another point? Yeah, you could have picked this point. So that point is 0.5 and 3. And we have this point, which is 1 and 6. So either of these 2 points, you would have found your unit rate, which k is going to be 6 anyway, and I'll show you why. So let's pick the point 1, 6. So you got k equals y, which is 6 over 1, and k obviously is 6. So the constant proportionality is 6, or if you write it in terms of unit rate, it's going to be 6 feet in 1 minute, right? If you were to choose another point, 0.5 and 3, 0.5 and 3. And if you didn't have 1 and 6, let's say you have 0.5 and 3, you would do the same. So you get k equals y over x. And k, our constant proportionality, is y, which is 3 over x, 0.5. And k is 6. So notice that they are the same. And if you write that in terms of unit rate, k equals 6 means that 6, which represents the y value, and here are my y values, right, is the distance, 6 feet over 1 meter. 11, which graph shows a proportional relationship? Well, we just talked about it. To have a proportional relationship, or a graph that has a proportional relationship, will go through the origin. This one does, definitely. Okay, that's one you can tell, linear. This one does not go through the origin, does not go through 0, 0, so this one is a no, and neither is this one. Find the unit rate Sam earned 2,988 in 48 hours. So let's do it the old-fashioned way. We can do it this way. 48 hours. We want to find the unit rate, which is 1 hour. So it's divide by 48 and divide by 48. No idea what that gives you. So 2,988 divided by 48 equals $62.25 per hour. So, but I also want you to know that you can do it this way. In this case, think about what your y and x is, input, output. So this would be your y value, this would be your x value. Okay, independent, dependent. Okay, so if I were to, and then to think about it in the graph, right? This would be your money, this would be your hours. So just assume that this is 48, and this way on the top is 2,988, and that would be the point that I am talking about, right? So this point, so to find the constant proportionality here, is 2,988 k times 48. And we're going to divide both sides by 48, which isn't that what you just did here? Right here, divide by 48. So I do the same thing. This side cross, and k equals 62.25, which is the constant of proportionality, right? And I can write 62 over 25 as a unit rate, and that's $62.25 over 1 hour. Number 13, okay, so there's the local dam lets 75,200 gallons pass through it over the course of 8 hours, and then the next day it does 141,000 over the course of 15 hours. Find the constant proportionality. That tells us how many gallons pass through the dam per hour. So they're looking for the unit rate, right? But we can go y equals kx. So let me write this as a rate first. So it's 75,200 over 8 hours. And again, I want, because we're talking about what do you call y and x, maybe you should think about it in terms of this terms, where this is the hours, my independent, and this is my gallons. So at 8 hours, and I'll put it over here, it's over here. The x value is 8, and the y value, it's a 75,200. So I can take that point, I mean, and I don't know what the line looks like, but there's, but I'm going to choose that point and find constant of proportionality, which is the unit rate. So again, you could, if you wrote it as a fraction, you could just divide both top and bottom by 8, and you would get the same answer. Or if we do it this way, y is 75,200 equals k times 8, which is the hours, and divide both sides by 8, and k equals 75,200 divided by 8. 9,400 is the constant of proportionality, or 9,400 gallons over 1 hour is my unit rate. I use the same thing on with the other point, and the other point, the other point is what? 15 hours. So again, using this same graph, 15 hours, maybe it's over there, and then 141,000 should be somewhere over here, right? So if I took this other point, I could have used either point to find the unit rate, but so I'm going to show you both, and then again, the unit of proportion. So you get y equals kx, or you could have just written k equals y over x. K equals, in this case, k, our gallons is 141,000 divided by, in this case, 15 hours. And our constant of proportionality, if you were to divide that, gets us exactly. So there's our constant of proportionality. And a unit rate from that, I can just say that's 9,400 gallons in 1 hour. And this is definitely proportional. Again, so let me just put those two. So if you were making a table, right, with several values, where this is my y and this is the x, the y is the gallons, the x is the hours, and one of the values here is that I had 75,200 in 8 hours. Then I had another value somewhere over here, 141,000 in 15 hours. So you could have picked this value or U value, and you notice that the constant proportionality is 9,400. So times 9,400 times 9,400. So there's your little proof that this is proportional, and we get our unit rate as well. 14. Which line has a constant of proportionality between y and x of 1? So let's look at line A, and let's just write, so I want k equals y over x, and somehow I want to find a line that where the constant proportionality ends up being 1. So let's pick a value. Let's pick a value on this line A, and the value I'm going to pick is this one. It's the only one that is perfectly, I can perfectly, what do you call, figure out the values. This one is going to be, no, I see my y-axis, no I do, my x-axis. This one I'm going to call 2 and 7. 2, 7, the point 2, 7. 2, 7. So if I plug it in here, I get k equals y, which is 7, and x equals 2. 7 over 2. Does that look like a 1? No. So it's definitely not A. Let's look at B. K equals yx. So if I substitute y and x, will I get a 1? Pick a point on line B, and there's so many points, and let's just pick this one. And that's 0.22. Let's plug it in. So y equals 2, x equals 2. Ta-da! K equals 1. So this is the one we want. Just to double check, let me pick a line on line C, just to make sure that line C also is not equals 1. So I'm gonna pick, what point can I pick here? Well, I think this one. It's 6, 8, so that's a 10, and this is a 3. So 10, 3, 0.103, where x equals 10 and y equals 3. Does that look like a 1? No, it doesn't. So the only one that has a constant of proportionality is letter B. They're all proportional, but letter B is the only one that has a constant proportionality of 1. Same thing. We want to find K, right? Which is our constant proportionality. And I need to pick a y and x coordinate plane. And I guess they picked one for us, 3 and 2. But there are several others we could have picked. We could have picked this one, which is 1.5 and 1. We could have picked this one, which is looks like a 6, 4. And I'm going to use 6, 4. Only because I don't want to use the one they gave us. You can use whatever you want. K equals 6. No, not 6. 4, which is the y value, over 6. And K equals 2/3. Okay. And there's one more thing I'd like to show you here. So notice that k equals 2/3 always is. It's also our ends up being our slope. Look, let's start here. If that was our slope, it means 2 up and 3 to the right. 2 up, 1, 2, 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 3 to the right. So that also is our slope. Okay. 16. A something took a car on 4 test drives. For each test drive, technician recorded times. Do the data in the table represent the proportional relationship. Okay, so I am going to switch things around. So this is the distance. This is the gallons, which is going to be, this is my y and this is my x. Okay, so independent, dependent. Think about that. So you can, I like to use a sentence. Does the gallon depend on the distance, or does the distance depend on the gallon? So obviously the distance depends on the gallon. So the distance is my dependent. Let me rearrange this in order. So I'm going to put 0.5 over here, and he traveled 12 miles. 1 gallon, he traveled 25. Oh, and I'm writing this the wrong way. So we have 0.5 gallons, 1 gallon, 2 gallons, and 4 gallons. 0.5 gallons, he got 12. 1 gallon, he got 25. And 2 gallons, he got 50. 4 gallons, he got 100. Did the data in the table represent a proportional relationship? Well, let's see if they have the same constant. So if I took this guy over here, right, and I wrote it as, found out what I call the constant of proportionality, or the unit rate. If I were to find the unit, so it'd be y over x, which is 100 over 4, and I get 25 over 1. So the constant proportionality is 25, and the unit rate here will be 25, what is it, miles? Miles in 1 gallon, right? So I can get all that information from 104. But with 50 and 2, so k equals yx. My y is 50, my x is 2, and you notice that the constant proportionality is 25. So the unit rate is 50 over 2, and you can tell that the unit rate would also be 25 miles over 1 gallon. So far, we're good. The third one, I'm not even going to do it because it's just going to be 25 over 1, and you see that the k, our constant proportionality, is 25, and it's 25 miles to the gallon. But when we get to 0.5, something happens. So k equals y over x, y is 12, and what do you call x is 0.5, and if you divide k, 12 divided 0.5, you get 24. So the constant proportionality is different. So this is the same, this is the same, this is the same, and this is not. Okay. So the data on the table does not represent a proportional relationship because of this guy over here. You notice that the constant proportionality is 24. Okay. Strategy: find the values of the ratio y over x. So again, you have 3 points here, and if you were to draw a line with a ruler, it does look like it's going to go through 0 or hit 0. I'm not too sure because I'm not using a ruler, but they don't want us to do this because actually, if it touched 0, you would just say yes, go through 0, so done. It's proportional, but because I'm not too sure, I'm going to pick the points. So let's start with this point over here, or not. And we have the first point, which is 3. And 7.8, if you put it in this format, you're going to get 7.8 over 3, remember. who's your x, who's your y, and that's going to give us, no idea, 7.8 divided by 3 equals, you got 2.6 as your constant proportionality. Let's take our second point, which is 6 and 15.6, likewise. K equals 15 over 6 over 6, and 15.6 divided by 6 equals 2.6. So far, so good. We have one more, which is 7 and 18.2. Hopefully, our constant proportionality will be the same. So you have 18.2 over 6, and you get, I don't know, 18.2 divided 18.2 divided by 6. That gives us what? 18.2. Invest in a calculator, Mr. Cho. And not, I don't know where I got 6. It should be 7. Sorry. 18.2 divided by 7 equals 2.6. And yes. So my guess in the beginning was that this is proportional because it will go through the origin, and all the constant proportionality are the same. So definitely, it does represent a proportional relationship. Hopefully, the audio in this video is going to be a little bit better. Hopefully, it's definitely longer.